Hello everyone, welcome to 10 DevOps tools you need to know as a DevOps engineer. This video aims to provide you with a comprehensive understanding of the core DevOps tools crucial for building effective DevOps processes. So let's dive right in. Tool number 1, GitHub. GitHub functions as a central collaborative hub for DevOps engineers, serving as the meeting point for both the developers and the operations team. This is where they unite to oversee and maintain their code, as well as manage its versions. For instance, let's say you work for a company like Apple, and you have to release iPhone 8, iPhone 14, and iPhone 14 Pro Max. In that case, a version control tool like GitHub will seamlessly facilitate the storage of these distinct code versions, making it effortless for monitoring and differentiating between them. GitHub's significance lies in its role to secure code repositories, safeguarding your software code and even the README files explaining the code. By adding README files to your project, you provide a user manual guiding others through the code purpose and dependencies. It also provides a good access control for its users. GitHub allows you to tailor up permissions, ensuring that only the authorized users or teams can make changes, hence enforcing security and project management. Before the introduction of a source code repository like GitHub, code storage was a chaotic affair, with copies stashed in shared network drives or even the developer's personal computers. This gave rise to version conflicts and even data loss sometimes. But having a repository to store this raw code is just step one of the process. You need to be able to build this code to a human-readable form, as well as test this code for bugs and vulnerabilities. And that's where the CI/CD comes to play. In the world of DevOps, CI/CD tools are the driving force behind the seamless automation of the code integration, testing, and the deployment process. Think of CI/CD as the engine that powers your software development, ensuring that the code changes are integrated, tested, and deployed efficiently. So let's say you want to release an application like Facebook.com, for example. In order to release that, you need to develop the code, store it somewhere, test that code, and then deploy the code for the end users to be able to use. In order to make this process automated, we then need a CI/CD pipeline, where CI stands for continuous integration and CD stands for continuous deployment. Several CI tools such as GitLab CI/CD, Circle CI, Bamboo, GitHub Actions, and more do exist out there. But Jenkins is literally one of the most used integration tools today. It's renowned for its simplicity, reliability, and adaptability. One of its standout features is that it's open source, meaning it's freely available and supported by a vibrant community. I've had a lot of people ask me, why Jenkins? And why is it important for DevOps? Its popularity lies in its simplicity and versatility. It has a massive library of plugins. This little add-ons allows you to extend Jenkins to work with almost any kind of code repository, build system, or deployment platforms you can imagine. It's like having a toolbox with unlimited tools. Also, its ability to automate repetitive tasks is very impressive. Imagine you're a chef, and Jenkins is your kitchen assistant. It takes care of routine chores like chopping vegetables or boiling water, so you can focus on the creative part of cooking. To truly master Jenkins, focus on understanding its core concepts. Think of them as a workflow that defines the steps your code will go through from integration to deployment. But where are we going to deploy this code? That's where tool number 3 comes to play, a cloud platform. As a DevOps engineer, it's important to have a mastery of at least 2 cloud providers. For example, AWS, Azure, or even GCP. Selecting the right cloud provider depends on your specific project needs. These platforms offer scalable infrastructure services, allowing you to provision virtual servers, storages, and network resources on demand. It's crucial to master resource provisioning, networking configuration, and security measures to ensure that your cloud-based applications are robust and cost-effective. But in order to host these applications on the cloud, you need something that is lightweight, and that's where Docker comes to play. Docker is used to package your application into portable containers. It simplifies deployment and ensures consistency across environments. Imagine Docker as a magic box where your application lives. And using these boxes, you can host your application on any server or container, making it easy to move it around. Many people think Docker is only about containers and Docker files. That's not entirely accurate. While containers are the stars of the show, understanding Docker commands is equally vital. These commands are like the secret spells that makes Docker perform its magic. To truly master Docker, it's important to explore essential topics beyond containers. Dive into Docker commands. Learn how to manage container networks and volumes efficiently. Discover the power of Docker Compose for orchestrating multi-container applications, and understand the importance of Docker images as well. While containers are lightweight and might have issues from time to time, it's important to have an orchestration tool that helps you manage them, and I will recommend Kubernetes anytime. Kubernetes is essential for container orchestration. In the past, Docker Swarm used to be very popular, but in recent years, Kubernetes has become the go-to choice for container orchestration. Kubernetes has grown past other orchestration tools thanks to its impressive array of advantages. For starters, it has a remarkable ability to automatically scale your application based on real-time demand. Think of it as an elastic band that expands and contracts based on the amount of traffic. Kubernetes also excels in load balancing, efficiently distributing incoming requests among containers while preventing traffic congestion and ensuring high availability. Moreover, Kubernetes embraces self-healing capabilities, continually monitoring the health of your applications and swiftly replacing or repairing the containers that falter. When it comes to updates, Kubernetes smoothly performs rolling updates, ensuring uninterrupted service as you gradually transition from the old to the new containers. But it's important to have a monitoring tool to detect any abnormalities in your cluster, and one very popular tool is Datadog. Datadog is very essential in Kubernetes, acting as a vigilant overseer of the cluster's health and performance. Datadog provides comprehensive visibility, alerting capabilities, and troubleshooting insights, ensuring your cluster runs smoothly and efficiently. With seamless integration to Kubernetes, it becomes a reliable partner which, like an experienced chef, understands every detail of the cuisine, helping you maintain the excellence of your DevOps operations. Terraform is also a very essential tool to master. It serves as a trustworthy infrastructure as a code tool, revolutionizing the way you provision and manage cloud resources. It empowers you to create, modify, and control your infrastructure using code, unlocking the potential for unparalleled scalability and automation. This infrastructure as a code, written in Terraform DSL, which stands for Domain-Specific Language, allows you to replicate your infrastructure consistently across different environments, such as the deployment environment, testing environment, and production. The magic of Terraform becomes evident when you master its core principles. First, it enforces a declarative approach, meaning you specify the desired state of your infrastructure, and Terraform handles the heavy lifting to make sure it comes to reality. It's like defining a dream house, and Terraform ensures it builds that house exactly the way you want it. Once your infrastructure is set up, having to deploy the application manually to your infrastructure could be really time-consuming. So a powerful configuration management tool that could help you simplify this process is Ansible. Think of Ansible as your automation assistant, allowing you to write playbooks, which are step-by-step scripts for managing server configuration and the deployment of that application. These playbooks automate tasks such as software installation, system updates, and configuration changes. Ansible is open source, and it's known for its user-friendly approach, making it accessible for DevOps engineers at every level of expertise. And for task tracking and collaboration, it's important to master Jira. Jira is a widely used ticketing tool for issue tracking and project management. Learn how to create, manage, and prioritize tasks using Jira to enhance collaboration and project organization. Additionally, familiarizing yourself with other ticketing tools like Trello or Asana really depends on your team's preference and workflow. Finally, tool number 10 emphasizes the importance of not shying away from coding. Whether it's mastering Linux commands or becoming proficient in a coding language like Python, Java, or even Ruby on Rails, sets you apart as a DevOps engineer. Knowing a coding language helps bridge the gap between the DevOps engineers and the development team, facilitating seamless collaboration and enhancing your troubleshooting capabilities. Start with the basics and gradually build your coding skills to become a versatile and valuable member of your DevOps team. In summary, these 10 tools constitute of a foundation for every DevOps journey. Each tool plays its distinct role in automating, managing, and optimizing your software development and deployment process. By mastering these tools, you will become a proficient DevOps engineer, capable of streamlining workflows and enhancing collaboration, and also ensuring the reliability and efficiency of your projects. If you love this video, please hit the like button and don't forget to subscribe. Until next time, see you. Cheers.